Okay, domain and range are just sets. So we're going to talk about domain as a set of all possible x values. And we're going to talk about range as the set of all possible y values for whatever it is that you've graphed or named. Because a function might not always be a graphed. All right, so domain is inputs or independent variable, and range would then be outputs. Don't need an S. Or dependent. All right. We always go smallest to largest or least to greatest. When we talk about these, we want them in order. All right, I'm going to fix that S real quick. All right, so let's look at this as a function. Do you remember this one from a few times ago when we were first talking about functions? The domain of this would be all of the different ways I could push a button and get it. So if I want to get M&Ms, I have to hit button A1. If I want to get a trail mix, I have to hit A2. So my inputs are the buttons. So if I hit A1, if I hit A2 and A3, I could also hit B1, B2, or B3. Then our range would be any of the type of candy or snack that I got out. So M&Ms, trail mix, chips, Skittles, Snickers, or Twix. All right, when we just have a discrete set that isn't an actual graph, we could write the domain is in set notation. So -2, 0, 3, 6, 8 is already in order. If a number repeats, you only write it one time. You don't need to repeat writing the number. Now this row is in opposite order, so I'm going to start with the -9, the -8, the 4, the 0, and the 6. That's my range. Same thing here, but I'm going to have to put it in order. So the smallest is -5, then -2, then 0, then 3. We only care about x values for domain. And for range, likewise, we only care about y values. So the 20, the -12, the 8, and 0. -12 is smallest, and then a 0, and then an 8, and then a 20. All right, this picture is telling us the 0.30, -2, -5, 7, -8, and 4, -4, -8. All right, so all I need to do for the domain is pick my x values and put them in order. So -4, -2, 3, and 7. And then the smallest on this one is the -8, and then the -5, and the 0. All right, Susie is having a birthday party at Jumping Zone. It cost $11 for each kid to jump. Her mom says she can invite a maximum of 4 kids. Make a table to show the cost of inviting 1 to 4 friends, then find the domain and range. So, is Susie gonna jump? If Susie's gonna jump, then 1 kid is gonna cost them Susie and 1 kid, so that's $22. 2 kids would be Susie plus 2 kids, so that would be 33. And then 3 would be 44, and 4 would be 55. So our domain is the 1, 2, 3, 4. It's already in order for us, that's nice. And our range is the 22, 33, 44, and 55. If you have a domain and a range on a graph that's continuous, we're going to write it as an inequality or write it in set notation, interval notation, sorry. All right, so x is we have to include the -4 because it's colored in. So x is between -4 and 3, or it's equal to -4. And we're gonna write everything both ways we know how to write it. So this would be -4 is less than or equal to x is less than 3. Or on the left we have a square bracket, -4. On the right we have a curved bracket on 3. I want both. All right, we're gonna think of the x and the y-axis as their own number lines. We're going to go from left to right. On x, and then we're gonna go from bottom, because that's the negative, to top on the y-axis. So let's look at what that looks like over here. So if I want to just deal with x values, I'm going to go from there to there. All right, so this is the domain. The smallest value is 1, 2, 3, -3, and that's a curved bracket. And the biggest value is 1, 2, 3, 4, 5, and that's colored in, so that's a square bracket. And we could write that as -3 is less than x, which is less than or equal to 5. So our x values range between -3 and 5. And then our range, we're gonna look, smallest is here, biggest is there. So my smallest value is 1, 2, 3, 4, 5, 6, so -6. It's colored in, so we're gonna get a square bracket. 2. It's curved, since it's not colored in, you could write that as -6 is less than or equal to y, which is less than 2. So we're gonna write both ways. Oops, I didn't erase it here. Let me erase it real quick and I'll tell you all these things. Thought I had erased everything yesterday, sorry about that. Okay, I am going to do these with you rather than just let you see them. So I'm going to mark on my x-axis, my smallest value of x is there, my largest value of x is there. So I am going from -1 to 2. -1 is an open circle, -2 to +2 is an open circle, and I would say -1 is less than x is less than 2. All right, along this axis, the smallest value is right there, the largest value is right there. So I'm going from 0 to 2. If I read it from bottom to top, open circles on both ends. So 0 is less than y is less than 2. This one's a little tricky, but it's not really, all right? So my smallest value of x is -4, largest value is 4, closed circle, so square brackets, -4 to 4, and we could write that as -4 is less than or equal to x is less than or equal to 4. And then the only value of y we have is 6. So we would write 6 in the square brackets like this, and then we would just say y is 6. There's no less than or greater than there. Okay. Smallest value on x and largest value on x. So we're going from -5 with an open circle to 15 with a closed circle. So -5 is less than x, is less than or equal to 15. And then on y, the smallest value is negative 10, largest value is 20, so negative 10 to 20. The 20 has the closed circle, negative 10 has the open circle. So negative 10 is less than y is less than or equal to 20. All right, notice x is here, y is here, because x is what are my domain is only x values, range is only y values. All right, I'm not going to erase and rewrite this, I'm just going to go through it with you. Will the domain and range of this function be written as an inequality or a set of values? Explain your reasoning. Okay. If it's discrete points, it's always a set of values. It's always going to be in set builder notation. I look at my x values, so only looking along this axis. I have negative 5, I have negative 2, I have 0, I have 2, and I have 4. Okay, start at the bottom. For y is for range. Negative 5, negative 3, negative 2. There's a value at negative 1 over here, and there's a value at 0 right there. That is where the domain and range come from. Okay, so if you have dots like this, you have sets like this. If you have curves or lines like this, you're going to have interval notation and less than, greater than inequality notation.